Hi, in this video we're going to find a side length of a right angled triangle using exact trigonometric ratios. And what I mean by exact trigonometric ratios is that we got sine, cos or tan of a nice angle. And by a nice angle I mean 30 degrees, 45 degrees or 60 degrees, because we find them in shapes like squares and equilateral triangles. So they're nice angles, and we can find sine, cos and tan of these angles exactly. And we saw how to do that in previous videos. Now, let's see what we want to find here. We want to find this side length x, and we've got this side here of 12, and we know this angle of 60. Let's think how we usually do this. Well, we've got this angle of interest. That's the known angle that's not the right angle. And then we label these sides where we know the lengths, or have labelled the lengths at least, relative to this angle of interest. Now, this side here is the longest side, so that's the hypotenuse. We label it with an H. I tend to put it in the circle. And then this side here is next to or adjacent to this angle of interest, and adjacent, I'm going to put an A like that. Now, remember we use SOHCAHTOA as a little mnemonic to remember which trigonometric ratio to use. SOHCAHTOA, like that. Now we're using A and H. A and H is here, so it's this trig ratio we're going to use. And remember that was short for cos. C is for cos. Cos of the angle of interest, theta, is A over H. So this is the theta here, the angle of interest. So let's just substitute into this. We've got cos of 60 degrees is equal to the A, which is 12, over H, which is x. And now remember, if the variable's in the denominator, the nice quick way we can deal with it is just swap the thing we're dividing by and the result. So we can swap this and this. We saw in previous videos why that works. So it's not just magic. So that becomes x is equal to 12 over cos 60. Now, the whole point of this video is that you need to be able to work these out, like cos of 60, without a calculator. So you could look it up in this table. If you can memorize this table, great. So we want cos of 60, we can see is half. But how could we work it out like from scratch each time without a calculator if you couldn't memorize this table? We want cos of 60. Remember that if we were trying to find sine, cos and tan of 45, we do a unit square like this, and then we cut it in half like that. And if we want to use 30 or 60, we do a equilateral triangle of side length 2 and cut it in half again like that. So we want to work out cos of 60. So we're going to do an equilateral triangle of side length 2, cut it in half like this. So we said it's side length 2. Now, because it's an equilateral triangle, if that's 2 and that whole thing is 2, that's half of it, which is 1. And then remember, we use Pythagoras to find the other length. Now, this is one of the two shorter lengths of the triangle. Remember, we can use Pythagoras. We do the square root of the difference of the squares. So we do 2 squared minus 1 squared, which is 4 minus 1, which is 3. Square root it is root 3. So that's root 3. And then this angle is 60 because the interior angle of a equilateral triangle is 60. And is it cos of 60? That's great, yeah. So this is the angle of interest. We label the sides relative to that. This side here is opposite that angle. So that's O for opposite. This is the hypotenuse because it's the longest length, H for hypotenuse. And this length here is A because it's adjacent to this angle. And then we can use SOHCAHTOA again. So SOHCAHTOA. We're trying to work out cos of 60. So we're using this one here. So cos of 60 is equal to the adjacent, which is 1, over the hypotenuse, which is 2. So cos of 60 is half, which we already knew from this table, but we were able to work out from scratch. So then this is now 12 divided by half, or 0.5, and 12 divided by 0.5 is, well, you can double top and bottom, so it's 24 over 1. So the answer is 24. And that's the final answer. X is 24 millimeters. The quick way you might have done this is that you can just say that, well, this here is an equilateral triangle, right? Because you've got this 60-degree angle here. So if this is 12, that's half the side length of an equilateral triangle. So this must be double. So you can see immediately x would be 24, and then you've got the answer straight away.